Right. One more example for object-oriented programming. The goal of this one and the last one with the faces was really to show you kind of where this can go. And if you apply these ideas, that some really, really cool stuff can kind of come out of it. So this is really a very different example. And I think it's really fun to look at things in the world, get excited about them, and then try to either recreate them in the computer or at least be inspired by them to give you ideas when you dive into code. And for me, one of those things is natural systems. So I was looking at lots of this like fungus growing and stuff like that. And I thought, okay, I really want to try to recreate this in the computer. Actually, let's make this a little bigger. It deserves more kind of screen real estate. And so this is also using object-oriented programming. Each of these tendrils, these little lines, is its own fungi instance. And then periodically, randomly, and according to other rules, it branches and then spawns a new one. And we'll look at a little bit of how that's kind of working. You can reset it. You can pause it. So if I hit the letter P on the keyboard, it stops it until I hit P again, which I kind of like because you can sort of see it happening. You'll notice it conforms to this circle, so it can't grow past kind of that distance. And there's some other stuff going on here that we'll talk about. We probably won't go into all the details of all the little pieces here, but I think this is a pretty cool, fun use of this. Okay, so, and like always, there's lots of comments in the code, so you can kind of check it out. You can hack it and change it. So I've got a list of fungi here, same thing with the faces before and the rabbits. I've got a paused variable. We'll look at how that's being used. And then this age variable, and we'll also talk about this. Now I'm drawing the background once because then I'm drawing each of these tendrils on top, and also we'll talk about this. And then the fungi, it becomes an empty list, just like with the faces before, and I'm using a for loop to start them. Now I'm only drawing 3 to begin with, and then because I keep adding more all the time. Then in the draw, if I'm paused, I don't do anything, actually. I just sort of skip ahead. And then if it's not paused, if it's running, then I keep going. I go through all the fungus objects. We go in reverse here. We'll talk about that in a second. I get the current one, I update it, and we'll look in the class in a sec. And then if its distance, which I'm calculating in the class as well, is too far or it's too old, max age is this variable up here, and that's in frames, then I remove it. I get rid of it. And so splice removes an item from the array at the index you specify, in this case I, and only one element. So that removes it, and then I display them on screen. Now the reason we go in reverse through the for loop has to do with this splice. If we were to count forwards and then remove something, well then the length of that array has changed, and in fact you might try drawing something that you've deleted. By going backwards, we remove it, and then we're kind of counting down, and anyway, it solves this problem. So it's a little funky, but if you want to remove stuff from the array while you're going through them, you want to go in reverse order like this, otherwise you'll get some errors. The other thing I have here is if the frame rate drops too low, it's going to start over. In the browser, it seems to do pretty well, but this just helps make sure, because we're keeping track of so many objects. There might easily be thousands here by the time it's done. So that's it here. Let's talk about what's going on in the class. And once again, I have imported it in my index here. You need to do that. So here's my class. So it gets an X and a Y, and optionally it gets an angle. We'll talk about that also momentarily. These values are going to be the same for all of these objects. Remember, a single fungus object is just one of these lines. So it's, this guy here, that sort of thing. Sorry, too much talking about object-oriented programming. Okay, so there's a few things, and these are going to be really fun for you to try to change and see how it affects this simulation. So the angle change, that's how much it sort of deviates, which is 2 degrees. The speed is 1. The chance of splitting is 2%. And then when it splits, when it divides off here, this is the angle at which it does it. So 16 degrees versus say 45 degrees. Let's try changing a few of these. So now you can see here it looks super, super different. By changing one number, we get this really, really different look. Much more geometric, more like cells or something, very strange. If we made this 2 degrees, now it's like, I don't know, grass or something. So, and it ends in a different way. Same thing with this angle change here. If instead of 2, it's 8, you can see it's actually a little hard to see. It sort of like wobbles as it goes. So this is kind of fun to play with. Yeah, you get this much more divergent kind of look. And depending on what you're after, this could be, really fun. Yeah, kind of like that. That's really cool. So you can play with those parameters. A few other arguments here. Actually, let's just reset that. That was 2. It may kind of freak out if you set some of these too far. Excuse me. Then we have our X and our Y, and a previous X and Y. This keeps track of where it's going to grow. Oh yeah, sometimes it kind of arcs around too, which is really cool. We'll talk about this in a sec. And then we calculate the distance from the center of the screen. That's how it knows if it should stop, if it's too far, and the age. And the age is going to get incremented every frame. And again, if it reaches a certain amount, then it gets removed. The angle, yeah, we'll come back to the angle. So then we have our update function here. I'm just going to stop this. You can see, it's getting to a point where it's bogging down the computer a little bit. So my update function is pretty simple. I'm increasing its age by 1. I'm calculating the distance from the center using this really handy function dist. You give it 2 x and y coordinates, and it does the Pythagorean theorem for you. Then I'm doing some random angle change stuff using this angle amount. So it's just, it's random. And then I'm using this awesome formula we've talked about a little bit, where you can calculate an x and y position from an angle and a distance. So for x, it's the cosine of the angle times the distance, and sine for y. And then randomly splitting into a new fungus. And this is kind of where the magic happens here. So if our random 100, again, thinking in percentage, 0 to 100 is less than that chance, then I create a new fungus object at the current position, and I use this split angle. So if my line is coming like this, and my split angle, let's say it's 45, then my new one is going to be at half of that in this direction, and it moves the old one in the negative angle. So it essentially does like this. So it takes the old one and it deflects it, and the new one, and it goes in the opposite direction. And then I add that to my list. Now, if you remember from before, we didn't send an angle in when we initially created these guys. We don't always send in this angle parameter. Sometimes it's just x and y. JavaScript lets you do optional arguments. Constructor is essentially a function. So what this says here is, if this angle value is present, then set the angle to that number. Otherwise, give it a random value. And this is kind of hard to read. There is an example in week 2 about optional arguments, so you can go back to that as well. It kind of explains it. But what this allows us to do is create either new fungi, tendril guys at a random angle, or to be able to do this split thing, which works really nice. So that's our update. I mean, I know there's a lot of stuff in here. You can kind of read through this, but what's really nice then is the display is really simple. All it's doing is drawing this line in the points, and that's it. So if we go back to our sketch and run this again, So if I, oops, don't want to put a P there. Let's start this again. So now you can see I've got these little tendrils. They're moving kind of at random wiggle wiggles across. Periodically, they meet the requirements to split, and the current line splits one direction, and the new one that gets created goes kind of at the opposite angle and is now a new fungus in our list. If they get too far, they're going to stop. And if they have lived for too long, too many frames, they're going to stop. We can also try changing this. So that's that max age. 10 is going to probably be too low. So, I've spent a lot of time with this, kind of playing with the parameters to see, you don't want it to die too quickly, kind of, but you also don't want it to go too far because then it really just never stops. So this is kind of nice. Anyway, this is by far, this is not a simple example. This is not like something that I made in a small amount of time. This is something I spent hours and hours kind of playing with, tuning, getting it to look really nice, getting the colors, all of that stuff. So I would really recommend, don't feel like this is something you maybe want to be able to make right out of the gate, but I think it's a pretty fun example of where object-oriented programming can take you something that this would be very difficult or impossible to make using more traditional methods that we've used so far. So yeah, again, dig into the code here and on the previous example if these are exciting to you and you want to see more about how they work. I'm of course happy to answer questions. So if there's something we didn't really get into and you want to ask, please do. Don't hesitate. But I think these are kind of cool uses of object-oriented programming, hopefully getting you excited to go make some crazy cool stuff.